students. In this class, we will start with the organic chemistry, the second PU. That is previous year questions from Haloalkanes and Haloarenes. We will start now. That is, so what they given from 2014 to 2020 and previous year questions from Haloalkanes and Haloarenes. We will discuss now and see your material. That is, which is previous year question papers material. You can see that. And which is a question number 1 to the Kcet 2014. Kcet 2014 you have to study. Right, that is first. Question number 1. Okay, that. Cell number 1. An incorrect statement. An incorrect statement with respect to SN1 and SN2 mechanism for alkyl halide is. With respect to SN1 and SN2, with respect to SN1. Nothing but unimolecular nucleophilic substitution reactions with respect to SN1 and SN2, and which is the wrong statement, incorrect statement, mechanisms for alkyl halide. Alkyl halide. First statement a strong option A strong nucleophile is an aprotic solvent increases the rate or favors the SN2 reaction. Generally, right, you know the well point, that is which is SN2 reaction is favored. SN2 reaction mechanism is very favored by strong nucleophile, which is SN2 reaction is which is increases in polar aprotic solvents, which is the right statement actually. That only given a strong nucleophile in an aprotic solvent increases the rate or favors SN2 reaction. So always the polar aprotic solvents, SN2 reaction is very favorable in polar aprotic solvents, which is the right statement. Next, computing the reaction for SN2 reaction is rearrangement. Actually, SN2 reaction is a single step mechanism, which is not the rearrangement takes place here. Right? There is no intermediate formation takes place also in SN2 reaction. So which is not rearrangement takes place, right? And but they given here the statement is rearrangement. It is a wrong statement according to the question, which is the answer. That is B. Next, option C. SN1 reaction can be catalyzed by some Lewis acids here. Right, which is so after elimination of halogen from the which is alkyl halide, getting the carbocation act as a Lewis acid here, which is sp2 hybridized Lewis acid. Tertiary butyl carbocation, different types of carbocations are formed from SN1 mechanism, which is can catalyzed by and some of the Lewis acids and which is the right statement, which is the correct statement actually. Next, option D is a weak nucleophile and a protic solvent increases the rate or favors SN1 reaction. A weak nucleophile must be replace that halogen in polar protic solvents SN1 reaction. So simple agagandre with weak nucleophile the reaction is that is SN1 with weak nucleophile the reaction SN1 which is a polar protic solvent is a more favorable solvents SN1 reaction. So that is also the right statement, but is the wrong statement is here. Computing the which is reaction for an SN2 reaction is rearrangement takes place and not rearrangement takes place SN2 here. And listen here, SN1, SN2 and few more information you have to study here. So what is that here? SN2 reaction is a bimolecular nucleophilic substitution reaction, which can occur in the single step reaction. Which is occur in the single step the mechanism in SN2. I am saying now the first SN2 in the single step the reaction takes place, right? And which is this SN2 reaction with strong nucleophile, which is favorable in polar aprotic solvent. That means polar aprotic solvent can favor the SN2 reaction with strong nucleophile, which is like the polar aprotic solvent like dimethyl formide, dimethyl sulfoxide and DMSO ether andre methyl polar aprotic solvent. What is the meaning of polar aprotic solvent? Which is the solvent which do not form the hydrogen bond with the substrate here. The polar aprotic solvents like ethane nitrile, like methyl acetate, methyl, which is ethane nitrile, you have to take CCl4, and chloroform, ಈ ತರ dimethyl formide, dimethyl sulfoxide, ಈ ತರ ಎಲ್ಲ polar aprotic solvents, ಆ solvents ನಲ್ಲಿ SN2 reaction ಚೆನ್ನಾಗಿ ಆಗುತ್ತೆ. Right? Always you must remember that point. SN2 mechanism is here. Right? The rate of SN2 mechanism is always the methyl halides are greater. Next the primary halides. Next secondary halides. Next the least one is tertiary halides. Tertiary halides. The rate of SN2 mechanism always. Which is so alkyl halides reactivity order. Reactivity order. Reactivity order. Which is right. The reactivity order of alkyl halides towards the SN2 mechanism, which is this one, which is so there is no intermediate formation takes place in SN2 mechanism. SN2 mechanism takes place through which is SN2 mechanism takes place through inversion configuration. Inversion configuration, which is inversion configuration, which settle like once you take that just an example here, which is an example is here when you take that methyl chloride, which is a methyl chloride when you take here, right? Then for this the OH minus nucleophile is attached to the from back side, which forms a transition state here. That is transition state is formed. In transition state the partial bond is formed between carbon and oxygen, and also the between carbon and chlorine, which is called transition state. Transition state, this is called the transition state. Right? In transition state, the partial bond is formed between oxygen and carbon, and also the partial bond is formed between carbon and chlorine. And will settle like whenever the OH minus nucleophile comes to attach forcefully to the backside of the methyl chloride, then will these three carbon and hydrogen bonds are there apart from each other, will settle like the umbrella structure, and that structure is also called, that configuration is called inversion configuration, which is called inversion configuration. And inversion configuration, right? So whenever these constant force and these bond away from each other, which is now, and hydrogen will settle like this here, right? The OH comes to here, which is attached, which is called methyl alcohol. Methyl alcohol, which is called, right? So methyl alcohol, which is called. Then plus Cl minus is leaves from transition state, which is called that. So which is a single step mechanism, which is a biomolecular nucleophilic substitution reaction. That means the rate in which both the concentration of alkyl halide and the nucleophile relatively depend ಆಗ್ತದೆ, which follows the second order kinetics here. Which follows second order kinetics. The reaction takes place through the transition state. The product is formed through transition takes place, and also the reaction takes place through inversion configuration, which is called inversion configuration. The product is formed. So the reactivity order towards methyl halide, towards what is it? Which is towards alkyl halides. Methyl halide is the first, then primary halides, then secondary halides, tertiary halides are no reaction here, which is. So why the tertiary halides are which is here? The reactivity nature is less here. Once you see that towards SN2 mechanism, see that when you take the example, which is primary halide, methyl halide, then we will take that primary, which is a primary halide, right? Then you have to take that secondary halide. Just example, just you have to take here secondary halide, right? Next you have to take the tertiary halide. Tertiary halide. Right. So which is the secondary, which is the primary, and which is called what is this here? And sorry, which is called the tertiary, and which is called the primary, and this is called methyl halide. Right. SN2 mechanism is more favorable towards alkyl halides of methyl halide than primary, than secondary, than tertiary. I give an order already for you, right? And because what is the reason? For all in cases which is a methyl, no nucleophile comes to attack to this carbons here. Nucleophile comes to attack here, which is nucleophile. OH minus nucleophile comes to attach here. So in where the nucleophile, which is easy to attach here, easy to replace this halogen. ಎಲ್ಲಿ ಅಟ್ಯಾಚ್ ಆಗ್ತದೆ ನೋಡಿ, ಇಲ್ಲಿ ಬಲ್ಕಿ ಗ್ರೂಪ್ಸ್ ಏನಿಲ್ಲ, ಇಲ್ಲಿ ಡೈರೆಕ್ಟ್ ಆಗಿ 3 ಕಾರ್ಬನ್ ಹೈಡ್ರೋಜನ್ ಬಾಂಡ್ಸ್ ಇದಾವೆ, ಹೋಗಿ ಅಟ್ಯಾಚ್ ಆಗ್ಬಿಡುತ್ತೆ, ಇಮಿಡಿಯೇಟ್ ಆಗಿ X leave out the methyl halide, which is X leave alcohol. Then in the case of this, we have the one methyl group, which is one methyl group. That means solid bulky nature excited. And the nucleophile more attached and capacity combined. That is called steric effect. We call this name. What is that? Due to steric effect, we call this name. Steric effect. Right? Due to steric effect or steric endurance, we also write. So the bulky nature is more. Now the nucleophile is entering capacity to the alkyl halides. In SN2 mechanism is less, decreases. Then in the case of this OH minus nucleophile is entered. But enter ಎರಡು ಗ್ರೂಪ್ಸ್ ಇದಾವೆ. ಎರಡು ಗ್ರೂಪ್ಸ್ ಅಂದ್ರೆ bulky nature ಇನ್ನೂ ಹೆಚ್ಚಾಯಿತು. ಅಂದ್ರೆ ಏನು steric effect ಅಂತ ಅಂದ್ರೆ cloud, electron cloud, which is more and more increases while going on the primary, secondary and tertiary. See, that's why the nucleophile is difficult to attach there from backside of the methyl halide. Right? And in the case of this OH minus nucleophile, it's also because very difficult to enter the OH minus nucleophile and attachment, because three bulky groups or three methyl groups are there, bulky groups here. Andre crowd ಹೆಚ್ಚಾಯಿತು, crowd ಹೆಚ್ಚಾಗಿದ್ರೆ electron crowd ಹೆಚ್ಚಾಯಿತು, ಹೆಚ್ಚಾಗಿರೋದು ಏನಾಯ್ತು OH minus nucleophile difficult ಆಗಿ enter ಆಗ್ತಾ ಇದೀವಿ. Right? And that's why which is here which is the tertiary alkyl halides are less reactive. Next the secondary alkyl halides. Secondary alkyl halides are less reactive than primary. Primary alkyl halides are less reactive than methyl halides. That's why methyl halides are more reactive due to the very less steric effect. That's why more reactive. That's why OH minus nucleophile is easy to attack here. That's why this is ordered. Right? And due to the steric effect, tertiary halides and secondary halides, tertiary halides SN2 mechanism is 100% zero, which is, and do not involve in SN2 mechanism. They involve tertiary halides ready SN1 mechanism. They undergo the SN1 mechanism, by the SN1 mechanism getting the product, which is right, and which is due to the steric effect we have in the, that is most important point. Right? And this is about SN2. I told you so much information, the many and the most important information I told to you, and while explaining the question only, one of the question, and hinde enide munde enide andre adu munche hinde enide and total information explain ಮಾಡ್ತೀನಿ, right? Then so about the SN2 is completed. Now coming to see SN1 mechanism, right? SN1 mechanism, just by taking an example here, then what are the main important points we have here, right? You have to take the tertiary butyl bromide, and in the first step, which is the step 1, in the first step, and which is occurring the slow step, forms the carbocation intermediate, right? And which is the intermediate, which is called tertiary butyl carbocation. Tertiary butyl carbocation. Right? And plus Br minus is forms here. Right? So for this tertiary butyl carbocation, right? Tertiary butyl carbocation, either side of the nucleophile which is attached here, that is in the second step, which may possibility for this tertiary butyl carbocation. Now the either side of the nucleophile, which is OH minus is a nucleophile from both sides. Just nucleophile is attached here. OH minus nucleophile. ನೋಡಿ ಈ ಕಡೆ ಸೈಡ್ ಇಂದ ಅಟ್ಯಾಚ್ ಆಗೋ ಚಾನ್ಸಸ್ ಇರ್ತವೆ, ಈ ಕಡೆ ಸೈಡ್ ಇಂದ ಅಟ್ಯಾಚ್ ಆಗೋ ಚಾನ್ಸಸ್, both sides. Then whenever the from left side the OH minus nucleophile is goes to attack to this what is that, carbocation, then which is called the carbocation. This character is a Lewis acid electron deficient species, sp2 hybridized the carbocations, which is having the 6 valence electrons in outermost shell. After formation of carbocation, 6-state configuration, which is a Lewis acid. Then next the OH minus nucleophile comes to attack here, which forms the compound is this. Right? And the OH minus nucleophile can also go to attack like this, just which is forms CH3, CH3, and now the product is forms here. Then and the products both are the butyl alcohols, tertiary butyl alcohol, ಅಂದ್ರೆ ಅರ್ಥ ಏನು ಹೇಳ್ತಾ ಇದೀನಿ, for this carbocation tertiary carbocation OH minus nucleophile is attached to either side of the carbocation, right? Chance ಇದೆ. Why? Because which is a trigonal planar geometry that is there, carbocation. So then which is the product is same. If you go the left side or right side, the nucleophile attack, which is getting the product is same, that is tertiary butyl alcohol. So but and from left to right and ಈ ಎರಡು ನೋಡಿ ಅಪ್ಪರ್ ಸೈಡ್ ಲಿಕ್ಕರ್ ಸೈಡ್ ಏನು ನೋಡಿದ್ರೆ ಮಿರರ್ ಇಮೇಜ್ ಅಲ್ಲಿ ನೋಡಿದ್ರೆ ನಿಮಗೆ ಮಿರರ್ ಇಮೇಜಸ್ ಈಚ್ ಅದರ್ ಬೋತ್ ಆರ್, and ಮಿರರ್ ನೋಡಿದ್ರೆ ಎರಡು they mirror images each other, these two products, and that is called racemization process ಅಂತ ಕರೀತೀವಿ. What is that? Racemization process ಅಂತ ಕರೀತೀವಿ, which is also called, right? See now, so which is a two steps process, which is a single step, not a single step, which is a two steps process, and a nucleophilic substitution reaction in which both the concentration of in which the rate depends upon only the concentration of alkyl halide is called SN1 mechanism, and rate depends upon only the concentration of alkyl halide but not in the depend upon the nucleophile, right? And it follows the first order kinetics. This is a two steps process. The product is formed through the intermediate carbocation, and also product is formed through racemization process, which is the product is formed through racemization process and also forms through the intermediate here, which is, and always the reactivity order tertiary alkyl halides are more, next secondary more reactivity, next primary, next the methyl halide. This is the reactivity order towards SN1 mechanism. Before this, any benzyl or allyl is there means, so benzyl or they are getting the more stable product, benzyl halides, next allyl halides, next one which is a tertiary, secondary, primary and methyl halides. This is our perfect order is this, which is reactivity order towards SN1 mechanism. Benzyl and allyl through the resonance stabilization takes place, getting the major product of alcohol, which is benzyl alcohol and allylic alcohol in the SN1 mechanism, which is right. And this is about just see, SN1 mechanism takes place through the intermediate formation. That intermediate is a carbocation, which is a Lewis acid, which is sp2 hybridization, and always the rate is depends upon where the intermediate is formed, there which is the intermediate is depends, that on that only intermediate is depends, which is the rate is depends upon on that intermediate only. Intermediate occurring step is a very slow step, and also the slow step is a rate determining step always, right? Slow step is the rate determining step, and also which follows the first order kinetics. The rate is dependent upon only the concentration of alkyl halide, and reactivity order is given, that is a benzyl, allyl, tertiary, secondary, primary, the methyl halides, right? And towards SN1 or SN2, the better leading capacity, that is Ri is the more reactive, next RPR, next R, what is that? Cl, the least one is Rf, which is the better leading group in the SN1 or SN2 mechanism. I minus is a better leading group, next Br minus, next Cl minus, next F minus in SN1 and SN2 reaction, right? So SN2 mechanism takes place through, which is racemization process also. So this is about SN1 and SN2, the clear information, complete information. And according to the question, if any question they will ask means you have to answer. Right. Next, go to the second question, 2015. Right. Second question. The arrangement of following compounds in the increasing order of their boiling points. Following compounds are given, that is one is, it is a bromo, bromomethane. Bromomethane. Next, second one is not options, just compounds are given. Bromoform. Bromoform. Next, the third one is here, which is chloroform. So chloromethane. Chloromethane. And fourth one is dibromomethane. 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 And the question is, in the increasing order of their boiling points. Their boiling points is, this is a question, right? We have the four options, right? In that the different numbers are given in the four options. Then what is the question here? See the second question. The arrangement of following compounds. They given the four compounds. The first compound is bromomethane. The bromomethane, first compound is a bromomethane, which is the formula CH3Br. Bromomethane. The second compound is given, which is a bromoform, like CHBr3, which is a formula CHBr3. Next, the third compound is given, chloromethane, andre CH3Cl. Next, the fourth compound is here, that is dibromomethane, andre CH2Br2, which is a formula. And what is the question here? In the increasing order of their boiling points, we have to arrange the increasing order of their boiling point. Yavudu jaasti, yavudu kammi anta arrange madabekku, the increasing order alli, right? You must remember one point is here, right? And wherever you go in the boiling points concept in organic chemistry, if you go to alkanes, alkynes, any functional group of boiling points you want to study here, which is must be dependent upon the mass. With increase in the mass, van der Waals forces are increases. That causes the magnitude of van der Waals forces increases. That causes the increase in boiling points, which requires the more and more temperature. Whenever the mass is more, whenever the number of carbon atoms are more, right? So where the more is the mass, there the boiling points are more. For that boiling points are more here. See, once you observe, CH3Br is there. And CH3Br ಇದೆ, Cl ಇದೆ, ಇಲ್ಲಿ Br2 ಇದೆ, only Br, ಇಲ್ಲಿ Br2, ಇಲ್ಲಿ Br3. ಯಾರಿಗೆ ಹೆಚ್ಚಿಗಿರ್ತದೆ ನಾರ್ಮಲ್ ಆಗಿ? Br3 ಹೆಚ್ಚಿಗಿರ್ತದೆ ಅಂದ್ರೆ second one is a more, which is right. Next Br2 ಅಂದ್ರೆ fourth one, which is why? Because carbon hydrogens all important. Br chlorine. Compared with the bromine, chlorine is less mass. So 100% which is least, right? Next. And after this, second one is what? CH3Br, which is the first one. Next one is fourth one. Next one is the second one, right? So second one, andre CHBr3 is a bromoform having 3 bromine atoms. Mass is again increases. With increase in the number of halogen atoms, what happening here? Mass is increases, and also the increase the van der Waals forces, and also increase the boiling points. That is the concept. So chloromethane, bromomethane, dibromomethane, tribromomethane is there here. So chloromethane has less boiling point because less mass than the bromomethane. And bromomethane of course increases here the number of bromine atoms. With increase the number of halogen atoms, bromine atoms, mass increase, boiling points also increases. And this is the order 3, 1, 4, 2. 2 is the more one, which is increasing order. Third option, option C is the right answer. 3, 1, 4, 2, which is the right. And also the one more concept among the isomeric alkyl halides one take just few more information. Ange explain ಮಾಡ್ತಾ ಇದ್ದೀನಿ ಅಷ್ಟೇ ಏನಿಲ್ಲ. ಕ್ವೆಶ್ಚನ್ ಆನ್ಸರ್ ಸ್ವಲ್ಪ ಇನ್ನೂ explain ಮಾಡ್ತಾ ಇದ್ದೀನಿ. Then ಇನ್ನು ಸ್ವಲ್ಪ among the isomeric alkyl halides one take, for example C4H9Br one take, right? Which is called butyl bromide. The butyl bromide can also write CH3, CH2, CH2, CH2Br. And we also write which is N-butyl. We call this name, what is this? N-butyl bromide, its name. Next, CH3, CHBr, then CH2, CH3, like this. which is called secondary butyl bromide. 2-bromobutane we also write. 2-bromobutane. 2-bromobutane we also write, which is called secondary here. Next we have to go with that CH3, CHBr we also write CH3, then CH2Br, which is called isobutyl bromide we also write. Isobutyl bromide. Right? Next, we have to take that same formula, that is tertiary butyl bromide, we have to take here, right? But among the isomeric alkyl halides, that meaning is having same molecular formula, but the length of the chain is different. With increase in the branching here, you must remember, of alkyl halides, with increase in the branching here, van der Waals forces are decreases due to minimize the surface area. So whenever the branching is increases, surface area is decreases. That causes the magnitude of van der Waals forces also decrease. Then finally resultant dipole moment is resultant boiling points are also decreases. So you must remember, with among the isomeric alkyl halides, nothing but having same molecular formula. N-butyl bromide, isobutyl bromide, secondary butyl bromide, tertiary butyl bromide, all they are having the same molecular formula, but the length of the chain is different. Where the branching is more, for that molecule having which is boiling points are less. So this is the boiling point order. More the surface area, more is the boiling point. You must remember, right? And this is the highest one. So least one, which is the least one. You have to take after this. Which is the least one? Tertiary butyl bromide is least one is here, which is right. So which is about the boiling points. Next, go with the third question. Third question. And the 2015 only 3 questions he asked. That is the hydrolysis of optically active. The hydrolysis of optically active. And the chiral molecule, nothing much. Optically active 2-bromobutane. 2-bromobutane. Right. With aqueous NaOH. With aqueous NaOH. Results in the formation of option A minus butane 2-ol, right? And option B plus or minus butane 2-ol. Next, option C plus butane 2-ol. Next, option D plus or minus butane 1-ol. Butane 1-ol. This is the question and the options. And what is here takes place? Listen carefully. Right. See that the hydrolysis ಆಗ್ತಾ ಇದೆ ಯಾವುದು ಒಂದು ಆಪ್ಟಿಕಲಿ ಆಕ್ಟಿವ್ ಕಾಂಪೌಂಡ್ ಕೊಟ್ಟಿದ್ದಾರೆ ಅಂದ್ರೆ which is a chiral molecule must ensure 2-bromobutane is a chiral molecule, then with aqueous NaOH. So aqueous NaOH ಅಂತ hydrolysis ಮಾಡ್ತಾ ಇದ್ದಾರೆ, aqueous NaOH ಅಂತ hydrolysis ಮಾಡ್ತಾ ಇದ್ದಾರೆ, optical activity compound that is 2-bromobutane, and results in the formation ಏನ್ ಫಾರ್ಮ್ ಆಗ್ತಾ ಇದೆ ಕಾಂಪೌಂಡ್ ಅಲ್ಲಿ ನಾಲ್ಕು ಆಪ್ಷನ್ಸ್ ಅಲ್ಲಿ ಏನ್ ಫಾರ್ಮ್ ಆಗ್ತದೆ ನೋಡೋಣ just which is called 2-bromo, right? CH, then CH3, C2H5, Br, which is called 2-bromobutane, which is called. So whenever the 2-bromobutane, which is first what happening here, according to the SN1 mechanism, the optically active 2-bromobutane undergo with aqueous NaOH, and which is undergo the SN1 mechanism. Right? SN1 mechanism means first it loses Br minus, which getting the carbocation intermediate. carbocation intermediate which is forms which is a secondary butyl carbocation is formed. And that secondary butyl carbocation, for that secondary butyl carbocation, whenever the actively active compound of secondary butyl carbocation and which is a carbocation is a trigonal planar geometry and 6-state configuration, I told already, right? And which is so now the nucleophile is which is attack at either side of the carbocation. Nucleophile is attack at either side of the carbocation. We told now one SNM mechanism. That process is called racemization process. One configuration is getting retention configuration, another configuration is getting inversion configuration, which is right. So either side of the carbocation can attack here like this, which is the nucleophile comes to attack either side of the carbocation. The product is formed here, which is whenever goes to attack here, which is a CH3, then which is H, which is a C2H5. Then here forms what is it now OH group, then which is called plus butane 2-ol. Butane 2-ol we call, and we have to take whenever the OH minus nucleophile is attacked here, and which forms here minus butane 2-ol, which is called plus or minus. Plus minus indicates dextro LIGO here, and minus butane 2-ol. Butane 2-ol, which is forms. And this mixture is also called racemic mixture. I told a mixture containing equal value, equal proportion of enantiomeric mixture, and that can indicated by plus or minus. I told here. So that's why which is forms plus or minus butane 2-ol is also called racemic mixture. A mixture containing equal value of dextro and LIGO rotatory compound of enantiomers. The optically have the optically activity is 0 optical rotation, which is getting. And that is called racemic mixture is formed through the racemization process of the enzyme, and both are mirror images each other, and plus and minus, then both are also called enantiomers. So the getting product is called plus or minus butane 2-ol, which is better. So what is the racemic mixture? A mixture containing two equal value of enantiomers, which is, that means dextro rotatory and LIGO rotatory both are equal mixture, equal value of the mixtures. Then which is both are mirror images each other and also called enantiomers, which having the 0 optical rotation. One enantiomer is get cancelled by another isomer. One isomer is get cancelled by another isomer, get have the optical rotation is 0. Optical activity becomes 0 for racemic mixture, which is so plus or minus butane 2-ol is called racemic mixture whenever the optically active hydrolysis compound with aqueous NaOH with NaOH, which is. So this is about the third option. B option is the third question, right? Coming to see now the fourth question. What is that? Enantiomers actually they are optically active isomers which are non-superimposable mirror images each other are called enantiomers. They are not overlap. They are not coincide when you see the mirror images. They are called enantiomers. You know the well definition already. Next, 2015, that is question number 4. Right. Question number 4. Right. So, what is the question? Bromohexane is given. Bromohexane plus Mg in the presence of dry ether. In the presence of dry ether. Then A and H2O, H plus B. Right. The product B is water. The product question the product B is B and the first bromohexane bromocyclohexane ತಗೊಂಡು ಮೆಗ್ನೀಸಿಯಂ ಅಂತ ರಿಯಾಕ್ಟ್ ಮಾಡಿದ್ರೆ ಡ್ರೈ ಆಫ್ ಡ್ರೈ ಇದರಲ್ಲಿ ಒಂದು ಕಾಂಪೌಂಡ್ ಬರುತ್ತೆ A ಅಂತ ಒಂದು ಕಾಂಪೌಂಡ್ ಬರುತ್ತೆ ಆ ಕಾಂಪೌಂಡ್ ಇಂದ ಮತ್ತೆ H2O ಅಂದ್ರೆ ಮಾಯಿಶ್ಚರ್ ಅಂತೀವಿ ರೈಟ್ ಅಂಡ್ ವಿಚ್ ಇಸ್ ಮಾಯಿಶ್ಚರ್ ಅಂತ ಟ್ರೀಟ್ ಆಗಿದ್ರೆ ಮತ್ತೆ B ಬರ್ತದೆ ಆ B ಏನು ಅಂತ ಕೇಳ್ತಾ ಇದ್ದಾರೆ ಅಷ್ಟೇ ದಟ್ ಇಸ್ ಸೊ first option A is here. Option A is here. And option A is MgBr, cyclohexane attached to MgBr. Option B is phenol is given. Option B is a phenol. Option C is cyclohexanol is given, not the phenol, cyclohexanol. Then option D is, which is cyclohexane is given, right? And this is the question and options are given, right? And see, listen carefully. And this is one of the concepts in the haloalkanes, that is in the chemical properties. Haloalkanes, how they reaction with the magnesium, that means metals are, which forms the Grignard reagent here. So alkyl halides, they treated with the magnesium metal, which forms the first Grignard reagent, is also called alkyl magnesium halide. See, according to this question, which is the solution is getting here, which is this is the bromobenzene. So now the Br plus Mg, which forms the product in the presence of dry ether. The presence of dry ether, then now MgBr organometallic bond is formed, which is called Grignard reagent. Right? So now that for that Grignard reagent, they given here. Here is the compound form, that is called Grignard reagent. Benzene ring, sorry, cyclohexane ring attached to hexane ring, which is attached to magnesium and Br. Carbon metallic bond is formed, which is so whenever that alkyl halide treated with magnesium, it's used Grignard reagent. That Grignard reagent I intend. Then for this again, A is treated with H2O. That means and the Grignard reagent is, I told the most important point. Grignard reagent is should keep the avoid from moisture. So after moisture is a place of it bad though, and a moisture is treat all immediate in the presence of H plus treat all alkane kottubudute, right? Andre this OH is combined with Mg and OMG OH and Br is separated. The remaining Hc is in this water, which is moisture, goes to attach here. Thus, which is forms cyclohexane. This is called cyclohexane is a product. And one most important point, alkyl halides Grignard reagent in the moisture dura ಮಾಡಬೇಕು ಇಲ್ಲ moisture ಇಂದ Grignard reagent ದೂರ ಇಟ್ಕೋಬೇಕು. ಇಟ್ಟಿನಲ್ಲಿ ಏನಾಗ್ತದೆ ಆಲ್ಕೇನ್ ಕನ್ವರ್ಟ್ ಆಗ್ಬಿಡ್ತದೆ ಆಕ್ಸಿಡೇಷನ್ ಆಗಿ, ರೈಟ್, ರಿಡಕ್ಷನ್ ಆಗಿ ಆಲ್ಕೇನ್ ಕನ್ವರ್ಟ್ ಆಗ್ಬಿಡುತ್ತೆ. ದಟ್ ಈಸ್ RH plus MgXBOH. MgXOH is a byproduct, which is so even on the basis of moisture is avoided from the Grignard reagent, because which is Grignard reagent is directly converted into alkane with the moisture. And also we have to keep away from, which is avoid the, we have to keep the with the Grignard reagent alcohols immediate react ಆಗ್ಬಿಡುತ್ತೆ. alcohol ಪಕ್ಕದ ಇದ್ರೆ ಸಹ react ಆಗ್ಬಿಡುತ್ತೆ Grignard reagent. And also amines primary amines secondary amines ಇದ್ರೆ ಸಾಕು, ಅಂದ್ರೆ moisture ಅಂತ react ಆಗುತ್ತೆ Grignard reagent, alcohols ಅಂತ react ಆಗುತ್ತೆ, ಮತ್ತೆ ಇನ್ನೊಂದೇನು amines ಅಂತ react ಆಗಿ immediate ಆಗಿ ಏನು ಕೊಟ್ಬಿಡುತ್ತೆ alkane ಕೊಟ್ಬಿಡುತ್ತೆ. immediate ಆಗಿ ಹೇಳ್ತಾ ಇದೀನಿ. ಅದಕ್ಕೋಸ್ಕರ the traces of contact of moisture, alcohols and amines we have to keep away from Grignard reagent, right? So if in case with the Grignard reagent they are present, means must be gives immediately alkane. Like that one of the reaction is given here. So that means bromocyclohexane, which is reaction with magnesium, which forms magnesium alkyl magnesium halide, right? And that is treated with the H2O moisture gives alkane, that is cyclohexane, which is the D option is the right answer. Next we have to see that sixth question. So fifth question to 16. Fifth question in the Kcet 2016. So reactivity order of halides for dehydrohallucination. Reactivity order of halides for dehydrohallucination. The best dehydrohalogenating agent, you know the well, alcoholic potassium hydroxide, alcoholic KOH. Dehydrohalogenation is right. And what is the reactivity carbon halides? Just he asked the halides. Option A is RF, RCl, RBr, RI. Next, option B, RI, RCl, RBr, then next RCl, next RF, which is right. Next option C, RI, RCl, RBr, RF. Next option D, RF is greater than, RI is greater than, RBr is greater than RCl. Right. This is the, so first reactivity order of halides for dehydrohalogenation, which is a better dehalogenating agent here, which is a better dehalogenation. This is order actually because large size and less nuclear force of attraction, easily elimination by breaking of less amount of energy by application. So RI is a more reactivity nature than RBr. Next one is RCl. The least one is RF, which is better and due to the large size and which is easy to elimination takes place from alkyl halide getting alkene here. See one example, you have to see that here. Just see, you have to take that CH3, CH2, Br, right? From alpha carbon you have to eliminate beta. Sorry, from alpha carbon you have to eliminate the halogen, that is the presence of alcoholic KOH. From alpha carbon you have to eliminate the halogen. From the beta carbon you have to eliminate the, which is hydrogen. So hydrogen halogen ಎರಡು ಎಲಿಮಿನೇಷನ್ ಆಗ್ತಾ ಇದಾವೆ. ಎಲಿಮಿನೇಷನ್ ಆಗಿ ಏನು ಮಾಡ್ತಾ ಇದಾವೆ ಅಂದ್ರೆ CH2 double bond CH2 plus KBr plus H2O, which is, and the eliminated Br is combines with KBr. The elimination of hydrogen from beta carbon which forms with water, with OH minus water, that is. So now the alkenes are the major products are here in dehydrohalogenation. So in dehydrohalogenation, the best which is in dehydrohalogenation, the preferred product is must be alkene, right? So in the case of symmetrical alkyl halides, getting the alkene is easily, but in case of unsymmetrical alkyl halides, the preferred product is must be alkene, which has greater number of alkyl group attached to the doubly bonded carbon atom. Is called Kcet rule. According to Kcet rule, major product is formed. The alkene is must be here, which has greater number of alkyl group attached to doubly bonded carbon atom. That is Kcet rule. According to Kcet rule, right? You know that is by taking an example here, which is by taking an example, that is a CH3, which is called CH3, CHBr, then CH2, CH2, then CH3, which is called. Right, once you observe this compound, then the alcoholic KOH you have to add. The best dehydrohalogenating agent, alcoholic KOH, right? So now the alpha carbon is this. From the alpha, Br is going to eliminate, and from the beta we have the two betas, which is the major product and which is the minor product, as which is so. And the major product is obtained from the beta carbon having the alkyl group, the bigger one, the bigger alkyl group. From the beta, when you eliminate the hydrogen, and that alkene is getting alkene is a major product. So which is a major product in the case of this CH3, CH double bond, CH2, CH3, which is called pentene, 2-pentene, we also write. Then and the one more product is formed, that is by taking, which is a CH3, CH2 double bond, 1-pentene. 1-pentene. So in dehydrohalogenation, the preferred product is must be alkene, which has greater number of alkyl group attached to doubly bonded carbon atom. Adartha enandre, in case of unsymmetrical alkyl halide, the hydrogen is eliminated from the larger alkyl group of beta carbon. Then getting the product of alkene is a major, which right? So ಇಲ್ಲಿ major important point, best dehydrolyzing agent is alcoholic KOH. That is must be remembered. Alcoholic potassium hydroxide, right? And which chemical product is must be alky, and that can follow in symmetrical alkyl halides Sergeant rule, right? This reaction is also called beta elimination reaction. We also write, because from the beta hydrogen you have to eliminate. So beta elimination reactions we also write this dehydrohallucination. The next which is we have to take 2000 which is 2017, 2018, right? 2018 you have to take. The 17th question already hydrocarbon chapter explain ಮಾಡಿದ್ದೀನಿ ನಿಮಗೆ Kcet 2017 ಕೊಟ್ಟಿದ್ದು, right? Next Kcet 2018 question number 6. Tertiary alkyl halide is practically inert, andre does not react ಅಂತ. Tertiary alkyl halide ಒಂದು ಎಕ್ಸಾಂಪಲ್ ತಗೊಂಡ್ರಿ, right? CH3 CH and CH3X, which is tertiary alkyl halide. It practically does not inert towards substitution by SN2 mechanism, because I already explained in SN1 and SN2 in this class only. That is the starting question. In the while going on the SN2 mechanism, that is in SN2 mechanism, methyl halides are more reactive, right? Next, the primary alkyl halide, secondary alkyl halide, tertiary alkyl halides. Almost the tertiary alkyl halides are inert towards the substitution reactions of SN2 here, right? Alkyl halides, right? Because what is the reason for this? And see, in the primary, I told already one methyl group is present. That means alkyl group is one alkyl group is present attached to that primary carbon, right? So the steric effect ಅಂತಂದ್ರೆ ಏನಂತಂದ್ರೆ due to the bulky nature ಹೆಚ್ಚಾಗ್ಬಿಡುತ್ತೆ. ಇಲ್ಲಿ ನ್ಯೂಕ್ಲಿಯೋಫೈಲ್ ಬಂದು ಹೋಗಿ ಎಂಟರ್ ಆಗಿದ್ರೆ ಕಷ್ಟ. ಎದಕ್ಕಂದ್ರೆ CH3 ಗ್ರೂಪ್ ಎಲ್ಲ bulky nature ಹೆಚ್ಚಾಗ್ಬಿಡುತ್ತೆ. bulky nature ಅಂದ್ರೆ ಏನಿಲ್ಲಿ ಕ್ರೌಡ್ ಹೆಚ್ಚಾಗ್ತದೆ. ಕ್ರೌಡ್ ಹೆಚ್ಚಾಗಿರೋ ಟೈಮಲ್ಲಿ ಹೋಗೋದು ಕಷ್ಟ. ನ್ಯೂಕ್ಲಿಯೋಫೈಲ್ ಹೋಗಿ ರಿಪ್ಲೇಸ್ ಮಾಡಿ ಹ್ಯಾಲೋಜನ್ ತೆಗೆಸೋದು ಕಷ್ಟ. ಸೊ ಅವಾಗ ಅದಕ್ಕೋಸ್ಕರ ಆಲ್ಮೋಸ್ಟ್ ಟೆರ್ಷಿಯರಿ ಆಲ್ಕೈಲ್ ಹ್ಯಾಲೈಡ್ಸ್ ಆರ್ inert towards SN2 mechanism, because due to steric effect, steric hindrance, we also write steric effect or steric hindrance. That is the answer. So what they given here options, first option A is insolubility and that is the wrong option. Next option B, instability is given. Next option C, inductive effect is given. Option D is the steric effect is given, steric hindrance, and that is option D is the steric hindrance is answer. So due to the steric effect, due to bulky nature, the nucleophile goes to attack the capacity of that carbon of tertiary carbon of alkyl halide is difficult in the SN2 mechanism. That's why inert nature due to steric effect. So which is the option D is the right answer, right? Next to the seventh question. Which of the following statement is true in case of alkyl halides? In case of alkyl halides, right? First option, they are polar in nature. Actually, they are polar in nature because see once, if you take the CF, if you take the CBr, CCl, CBr, then CIr, which is right. If you take that, because the carbon halogen bond is polar in nature, because halogens are more attracted to their carbon. The halogens are getting partial negative charge, the carbon is getting partial positive charge. They are polar in nature. All they are polar in nature. So that is the right statement. They are polar in nature. They cannot form hydrogen bonds. So ಅದಕ್ಕೆ ಹೇಳ್ತಾ ಇದೀನಿ, actually alkyl halides are they are poorly soluble in water, because the reason here they are do not form the hydrogen bonds with water. They having van der Waals forces between the haloalkane. They having the water hydrogen bonding when dissolved in haloalkanes in water, but do not form the hydrogen bond, the alkyl halides with water, do not form hydrogen bond, and that is the right statement, which is they can form hydrogen bonds ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ, ಅದು ರಾಂಗ್ ಸ್ಟೇಟ್ಮೆಂಟ್ ಆಗುತ್ತೆ. ನೆಕ್ಸ್ಟ್, they are highly soluble in water. insoluble ಆಗಲ್ಲ, They are poorly soluble, they are slightly soluble in water. Haloalkanes are slightly soluble in water, but they are readily soluble in organic solvents like benzene, ether, carbon tetrachloride. Ether compounds only dissolve ಆಗ್ತವೆ. Next, they undergo addition reactions. They do not undergo addition reactions. They undergo nucleophilic substitution reactions. I told so many nucleophilic substitution reactions. You know that how the nucleophile by SN1 and SN2 mechanisms. The getting the products are here in the nucleophilic substitution reactions. So, according to the question, which of the following statement is true in case of alkyl halides? The first statement, they are polar in nature, is the right statement, that only correct statement. But remaining the B, they can form hydrogen bond, is a wrong statement. They are highly soluble in water, they are also wrong statement. And which is a D, they undergo addition reactions, also wrong statement. Which is the first option is right option. Okay, now, and these are the few questions and few more questions we have to discuss the next question onwards, right? In the next class, that is the 8th question onwards, and remaining questions what they are 2019 and 20 and what they given we will discuss in the next class, right now. Thank you.